We're going to identify the slope and y-intercept of a linear equation based on its formula, and then use those to draw a graph of this linear equation. So to start, the general slope-intercept form is y equals mx plus b. Where m is our slope and b corresponds to the y-intercept. So with our example, we're told to identify the slope and y-intercept of the linear equation y equals 5x plus 2, and then we'll use that to graph this equation. So with y equals 5x plus 2, we can see that the coefficient on x is 5. So our slope here, which we'll use m to denote, is 5. The y-intercept, we can see that we have plus 2, 2 is the constant term, so our y-intercept will be the point 0, 2. Now when we graph this, we'll anchor this graph with that point 0, 2, and then we'll use the slope to find other points on the graph. To start, we'll scale and label these axes, and I'm going to use this 10 by 10 grid and label off x and y, which are my variables, and then I'll scale those axes by making each grid worth 1 unit. So I'll mark off 5 and 10 for x and y, and then I'll mark off -5 and -10. I could mark off more units if I want, but I've shown a consistent enough scale here. Okay, so starting with our point 0, 2, we'll go to where x is 0 and y is 2 to plot this. And then we're going to use that slope of 5 to find additional points. And with 5, it can be hard to see this as a ratio, so it's important to remember that every integer can be written as a fraction of itself over 5. So we can write m as 5 over 1, and that can help us see our rise over run. So from that point 0, 2, we're going to go up 5 units, right 5 units. That's +5 over +1. So I'll go up 5 units and right 1 unit, and that will put me at the point 1, 7. So I'll add that point to the graph of this equation. Now, to find more points on this graph, 5 is a pretty steep slope, so I'm not going to be able to put any more in that first quadrant. I can, however, also write m as -5 over -1, which is a pretty complicated way to write the number 5, except it's helpful in this case to recognize that 5 is equivalent to -5 over -1, because now I can move from that point 0, 2 and go down 5 units, left 1 unit, to find another point on this line. So moving from 0, 2, I'll go down 5 units, so I'll be where y is -3, and left 1 unit, and that will put me at the point -1, -3. So I'll mark that off on my graph as well. And I could do this once more. I could fit one more point in this third quadrant. So moving from -1, -3, I can go down 5 units again and left 1 unit, and I'll be at -2, -8. Now I want to connect these points to represent all solutions to the equation y equals 5x plus 2, and I'll grab my ruler and line it up along those points to do so. Now that I have my ruler lined up, I'll draw a line through all of these points, and then I'll add arrows to the ends to show that it continues on indefinitely. I'll write the equation, which is y equals 5x plus 2, next to this line as a label.